Yes. So I said we are going to make guessing game. So we'll think of a number and then we'll try to guess that number. So we'll make a simple example first and then we'll slowly add features on top of it. So let's say the number is 65. Okay. And now we have to guess the number. So I'm going to say, uh, you know, guess equal to int of input, right? We are going to ask the user guess the number. Okay. Now, if you guess it correctly, okay, so that means if guess is equal to num, then you say print congratulations, you have guessed it correctly. Okay. Else, sorry, it's incorrect. Right? Okay. So when you run it, P1, right? Yeah. So when you run it, it's asking us to guess the number, correct? So I'm guessing the number. Let's say I guessed 55. Obviously, it's wrong, right? So it says incorrect. Now, what I'll do, we will try to put it in a loop, okay? So that you keep on guessing till you guess it correctly, okay? So let's say I put, so the guess should also be the loop, right? Every time you have to guess a new number. So I'm going to say while true, right? While true, and you put them all inside. So it's while true. Now, when you guess it right only, you'll come out, isn't it? So when you
Mhm.
guess it correct, I'm going to say break here. Okay. So now when you run it, guess the number. Let's say I gave 55. Sorry, it's incorrect. Okay. I say 45. It says incorrect. 75, incorrect. And now I say 65. Okay. So it says, you guessed it right and the loop stopped. So we are talking about break here. Break will throw you out of the loop the moment you execute break when you see it. So now this could be in another loop. So the break will throw you out of the existing loop. So if this is in another loop, this another loop will continue to run.
Mhm.
If this another loop, this will continue to run. Only the inner loop will be thrown out, right? Now you can have something inside this. Okay. Now, since you're calling the outer loop here, you have inner loop will automatically get cancelled, right? So what you're saying is break will throw you out of the existing loop, right? If there's an inner loop, obviously you are out of that. If there's already outer loop, so that loop will remain, right? That loop will not go away. Okay. Now here, we'll make one improvement here. So instead of saying sorry, it's incorrect, let's give some hint. Okay, so let's say that we will give a hint that the number is higher or lower. Okay, okay, no. So before that, okay, before that, let's count how many chances you take to execute it correctly. Okay, so I'm going to define attempt here something called as 0. And every time you make a guess, you're making an attempt, isn't it?
Mhm.
So I'm going to say here attempt equal to attempt plus 1, or you can simply say plus equal to 1. Plus equal to 1 is same as saying attempt equal to attempt plus 1. Okay. So now here you will say you have guessed it correctly in so many attempts. In so many attempts. Okay. So this will put as F and we'll put attempt here. So now when you run it, okay, guess the number. Guess the number. I'm guessing, let's say 55, 45, 55, 65. So it took 4 attempts, right? So you see, you guessed it in 4 attempts. Okay. Now let's make it truly, what do you say, guess. So we have something called as random, right? In programming languages where you can borrow random numbers. So I'm going to say import random. This random will give us functions which will help us to access the values, random values, okay? Which will help us to access random values, okay? So since I want random values, I'll use random. And random has multiple functions, which we'll see later also. Here, one of the function is called random int. Random int. Sorry. Random.randint. Okay. Now, randint is a function, okay, which takes two values and it will return you a number, random number between 1 and 100, both including. Okay. So if I say randint 1 comma 100, it will give us 1 second. Okay. So I was saying that rand int will give us a random number between 1 and 100. So you have 1 and 100. Between 1 and 100 will give you number both inclusive. Okay. So both inclusive 1 and 100. Okay. So see, what we'll do is we will print it just for our knowledge. Okay. So that we see what number it is there. Okay. Otherwise, it will be totally blank, right? So just we'll display it now here. So now let's play this game again. So this time it says 97. I'm going to say 45, incorrect 89, incorrect 97. Okay, 3 attempts, right? Okay. Now what we'll do is, okay, we will make computer, okay, guess that number. So instead of we guessing, right? See, computer is guessing this num and let computer only guess the guess also. So I'll say here guess equal to random dot randint 1 comma 100, right? And let's see what happens. Let's see the magic. It took 143 attempts to guess, right? We'll write it again. This time it took only 54 attempts, 136 attempts, 61 attempts, right? So let's try to see if we run it 5,000 times or 10,000 times or 500,000 times, what is the average number that it takes? Okay. Okay. So we will declare a variable called total attempts. Okay, we'll set it to 0. And we'll have number of times that you want to guess the number, right? So I'm going to say n equal to, we'll start with 25,000, let's say. So we'll run this whole thing 25,000 and we'll see what is the average, how much time does it take, how many attempts it takes to guess the number. Okay. So this and so this is attempt per attempt, right? Now what we'll do is total attempts. Okay, we need to capture the total attempts, right? So what we'll do, okay, here when congratulation happens, I'm going to say total attempts equal to total attempts plus attempt, correct? Okay, and outside when we are done, right? When we are done, we'll say print, okay, average number of attempts it took would be your total attempts by the end, right? n that we have, 25,000. So that will tell us the total attempts. Now we need to run this n number of times. Okay. So I'm going to say for I in range, okay, n, right? So this whole thing will run 25,000 times. Now you see, there's no need to say, sorry, it's incorrect, right? Because it's going to print it 25,000 into 100 times, maybe few, I mean, lot of times. So I'm going to comment it out. Instead, I'll give pass, right? We say pass, right? When we don't have anything to do.
Mhm.
Okay. So any other changes we have to make? Now see, this attempt has to be 0 after every attempt, before every attempt, right? So this has to go inside this, right? Because after you start, it has to be 0, right? That's how you're able to count the attempt. Okay, so this is set to 0 every time. Okay, so you have this. Okay, now let me also talk about min and max. Okay, max attempt. We want to capture the max and min also. So 0 is total attempts. Max will put some 0. Okay, so we'll say minimum it's 0 attempt, and minimum will put some very high number. Okay, 9,900 to indicate that minimum is so much, and then here we are going to compare. Okay, so if minimum is less than, or if minimum is greater than the attempt, right, then min equal to attempt. That means if you have guessed something in lower than the previous attempt, right, if your attempt, okay, is smaller, right, if your attempt is smaller than the min, then the minimum should be attempt. And similarly, I'm going to say if your maximum is lower than the attempt, then maximum equal to attempt, right? And then we can print here maximum attempt equal to, we'll say max, and uh, and minimum attempt comma min. Okay. Okay, so hopefully this should run correctly. Let's run it and try. It has to do 25,000 times. So see, average number of attempts it took is 100. And maximum was 958 also, see?
Mhm.
And minimum is 1 attempt. Okay, so in 25,000 times, it could attempt in, this is how, this is called simulation, okay? This is how simulation happens, right? If you want to know, like, uh, you have uh, you have written a bad code. You know that you have written a bad code, and you want to see when will it fail. So you can create a simulation, okay, and see that, okay, this is the maximum attempt that the user can take. 958 is the maximum attempt, and you run it again, okay. The print will take a lot of time, okay. If we comment this print also, right, this print, it would be even fast. See, it took now almost 1,000 times maximum, but average is around same time. You see that?
Mhm.
So that's why we say average, right? When you toss a coin, if you toss a coin 3 times, 10 times, 15 times, you'll get biased output. But when you toss it 1,000 times, 10,000 times, 100,000 times, you will get 0.5, 0.5, right? So see, on average, it is like 100 both the time, right? I'm going to comment it out, and now I will make it as 250k times. Let's see. Now you see, this number is not changing because we have kept this number outside the loop, right? This number is not changing. What is changing is inside this. So see, 99. So even that many times it took 1300. See, the worst was 1300, but average is almost 100. Okay, so it ran so many times, right? But we didn't know what is happening, right? So what we'll do is, okay, now we will print and we'll say 1% done or 2% done or 3% done, right? Or 100% done. So for that, I'm going to use something called as a list. Okay, list will have a value here. Okay, so generally list will have, you can use a string as well. We haven't used string also, so it doesn't matter. Okay, let's use string. Okay, so what I'm going to do is, I'm trying to make a little more fun, and we can try to see different types of logic getting built here, because after this the next topics are all learning something new every day. Okay, so the main core logic is here. By now you should be able to develop any logic. Okay, that's the intention. Any logic using Python, basically, right? So what we'll do is we'll show this line, okay, and this will show us like 1% complete or 10% complete, or 2%, 3%, 100% complete will show. So how do we do that? Okay, now okay, let's use this. Now see, if you have percentage will be 100, right? That means n by 100 is your is your what do you call, like that much percentage been done, right? So 250 by 100, okay, that means when you divide and you get um when you get a perfect number, right, then it's 1%, correct? Okay, so let's see what I mean. You have n and pc, correct? And let's say we'll put it here when it is equal to, right? That's when we'll see before break. Okay, now you have k equal to, okay, k equal to n by pc, but k equal to n by pc when if n modulo pc equal to 0. That means n is your 250k, and if you divide by 100 and if it is equal to 0, that means perfectly divisible. That means you get 100, 200, 300, 400, 500, right? So will that be your thing? No, right? Obviously not. So when you divide, okay, so instead what I'm saying is, okay, so let's say I put if, I'm trying to understand when is 1% done. Okay, 1% will be done when n by PC, that means 250k by PC, okay, is equal to, okay, I equal to, and this has to be integer value, right? So I want to calculate. How do I calculate? I want to calculate percentage. You think, are you getting what I'm trying to say? So
Yes, yes.
250K by 100, that means if it is equal to this much, I want to display as 1%. Now, how do I make sure that I get this number, right? So if I divide this by 100, okay, and um, so it is multiple of 250, right? It's your multiple of 250, correct? That means, okay, okay, I think I got it. So PC will be n by n double divided by 100. So n divided by double by 100 will be this one, right? Now if I is a multiple of this, that is 2500 or 5500, 5000, then okay, then so if PC modulo I equal to 0, then you say that much percentage completed. So I'm going to say print, okay, okay, comma, percentage completed. Let's see if this works or not. Otherwise, we'll come back and see. Let's run it and see. Oops, zero division. uh, PC modulo I. So PC is 2500 divided by 0. Okay, divided by 0 is coming. 1, 2, 3. No. If I modulo PC, I think this is what it should be. If I modulo PC, okay, is coming,
Is
then
i-
I by PC.
is it like the number of attempt divided by total number of attempts into
Correct.
100?
Now you see 0%, 1%, 2% completed.
Yeah.
See that? Okay. And after 100%, it should stop. That means we got it right. So earlier, like, we were waiting, we didn't know program is running or not, whether it's working correctly or not. So
Mm-hmm.
now we have cracked. So it's telling us so much percentage completed. Right? 99, and then this is 100% done.
Mm-hmm.
Okay. Now you see it's taking 1200 times, on average 100 times. It's because we are not giving enough hint to it. Right? Now, can we give a hint? Okay. Can we give a hint? What I mean to say is, else it is incorrect. We know that. But instead of saying incorrect, okay, instead of saying incorrect, can we tell whether it is more or less? Okay. Okay. So what I mean to say is, I'm going to comment this for now, and let's use this guess. Okay. And when you go to else here, okay, you will have three conditions. Elif, see, here we're talking about guess equal to num. So this is everything that we want to do. Now there are two more possibilities. That means guess is greater than num, or in else you'll have guess is less than num. Right? That's what else will mean. So now I'm going to print a message saying Okay. Sorry. Guess is higher, right? So, no, guess is higher, right? So, actual number is smaller, correct? And here I'll say, sorry, actual number is greater. Okay, I'm doing it manually, let's say now. Actual number is 35, right? Guess the number. So I say 45. So see, it says actual number is smaller. The moment you say actual number is smaller, what happens now? Now our mind will not go beyond 45. Will think below 45 only. It will be much faster, right? So now I'm going to say 10. It says, sorry, actual number is greater. Now we know that it is between 11 and 44. I'll say 30. Actual number is greater. I'll say 40. Actual number is smaller. So I'll say 35. And you get it? 35. Okay. Uh, okay. 0% completed, right? But we did not print every other things. I think I have not done this, right? Otherwise, you would have said, congratulations, you have got it right in so many attempts, right? So this is how you can check it manually, right? So this is manual. Now, same program, okay? Now I'm going to do it using machine, okay? So when you guess, so I'm going to comment this all print here, this print also. Now you see, instead of guessing this into 1 and 100 every time, okay, I want to change these values based on the output. Okay, so what I'll do, I'm going to say start comma end equal to 1 comma 100. So the first guess obviously has to be your start and end, correct? Now this start and end is 1 and 100, but every time you make a guess, this should be changed. How? If guess is higher, that means you have guessed a higher number, right? So next time your end, right? This is end I have used, correct? So your end has to be okay, guess minus 1, isn't it? So when our guess is higher, let's say you have thought of 45, actual number is 45, you thought of 80. That means your guess is higher. So next time you should not think beyond 79. Yes? And similarly, when you're when you have thought of a lower number, next time you should not think lower than that. So it should be guess plus 1.
Mhm.
Now when you run it, okay, and instead of manual, we'll make it, yeah, computer, right? Now you see, the performance will be much faster. So see here, it average number of attempt is just 1. Imagine. Maximum
Wow.
is 7. Minimum is 1. See, from 100 times improvement. 1, 1, 6 time. Maximum is 6 time only,
Yeah.
right? Because now you know that, you know, how much to think. Now this is also because, you know, you are thinking same number here. What I'll do, this number also, okay, the number that we are thinking, okay, I will put it inside the loop. So let this also change every time. Even then, you won't, okay. What it says? Are we using n here anywhere? Here we are using n, right? No. Oh, Why it's giving error? Should not give error, right? Okay, your start and end. Okay, the start and end should also change. Okay, I think this is the mistake we made. Every time you start the loop, the start and end should change, right? Yes. Now you see. See, that was a mistake we made here. It should not, it should be inside for loop, not outside. Now you see, maximum attempt is 23, minimum attempt is 1, and on average it took 7. This is right. Previously it was wrong because we gave this outside, it always worked. Now it has to be inside. So now even if I put this outside, I don't think much change will happen. Okay, if you see. Okay, 8, 22. Yeah. So now you see. So now we are giving hint and our program is much faster.
Mhm.
It's taking on average 8 steps only. Okay. We have something
Yeah.
called as continue. Okay. See now, see the guess number we know is between 1 and 100. Now if guess is greater than 100 or guess is less than 1, then we say continue. Now this is not going to happen. Okay, this is not going to happen because we are using inbuilt, but manually when you do, it might be possible. So what I'm saying is, if you are guessing, if your guess number is more than 100 or if it is less than 1, then continue. Continue will take you to the beginning of the loop. Continue takes you to the beginning of the loop. Now see, break and continue works only for loops. Break and continue works only for the loop, and break means throw you out of the loop. Continue will take you. So all these things will not happen. All these things will not get executed. The moment you say continue, it goes up to the beginning. Okay, all these things will not happen. Okay, so this is how you can do this. We'll stop here for today.